Streaming in 126 countries on 43 podcast platforms. We are now closing in on episode number 200 here at the Tech Ed Podcast, by far the number one podcast in all of STEM and technical education. So glad you're with us this week. My name is Matt Kirchner, and I am your host this week and every week. You know, we've talked a lot over the course of the last year about the world of energy as it relates to STEM and technical education. You know, one of the most memorable episodes for me, I love last year of 2024, was Mary Snap of Microsoft, Senior Vice President of Strategic Initiatives, who joined me as Microsoft builds a $3.3 billion data center right in my backyard here in Southeast Wisconsin. Big data, artificial intelligence, machine learning. We think about the technology, we think about the applications. What sometimes we don't think about is that these technologies are consuming tremendous amounts of energy. And so we are living in a world where, as much as we talk about sustainability, as much as we talk about energy efficiency, the truth of the matter is we are probably going to be consuming even more energy than we have in the past. How do we do that safely? How do we do that sustainably? How do we do that economically? How do we do that sensibly? We are going to talk about all of that today with our guest. His name is Patrick O'Brien. Patrick is the Director of Government Affairs and Communications at Holtec International. You're going to know a lot more about his company as we get into the conversation. I met Patrick a number of months ago. What they are doing in the world of nuclear is absolutely fascinating. You're going to have a great time listening to this episode and learning from Patrick. But let's start here. Patrick O'Brien, so awesome of you to join us at the Tech Ed Podcast. Thanks for being here.
Super happy to be here, Matt. This is fantastic.
We're going to have a wonderful conversation about the world of nuclear energy. We are in a nuclear energy renaissance, whether people really believe it or not. Public perceptions of nuclear energy, safe use of the technology, and so on. So many great things going on, and you are right at the heart of all of this. So let's start with this. What is the nuclear energy renaissance? Why are we hearing so much about it? And I'd be interested in what you think is driving this renewed interest in nuclear.
Yeah, I think it's a great question, Matt. And I think you touched on it in your intro, really the growth needed going forward from both electrification of a number of different resources, including cars, but also really the big tech companies that are now really pushing forward with the AI. Something as simple as a Google search. If you do the same thing under AI, you're using 10 times as much power. So, the consumption has grown. We don't have the flat, energy growth curves that we kind of had for decades, where you kind of saw nuclear shutting down for the last, maybe decade or so. You've really seen a change in an appreciation of the clean baseload power that it does bring.
So the shutdown of nuclear, how far does that go back? I mean, when did that trend really start? Is that like 3 Mile Island and that kind of thing? Maybe a little bit later, or
No,
just
later.
Give us a little bit of the history.
Yeah, sure. No, a little bit later. Really, when gas got pretty cheap, late 2000, early 2010, 11, that
Got
range,
it.
started to see plants like Vermont Yankee shut down in 2014, Pilgrim in Massachusetts 2019, Indian Point 2021, 2020 for different units. So a lot of the non-regulated markets, you started to see kind of that decline and not really an appreciation for the assets as clean power versus just cheap natural gas.
Yeah, absolutely. And I lived through the days of natural gas being, $12, $15 a decatherm in the early zeros. And certainly we're nowhere near that now, haven't been for the last 10 or 15 years. So I suppose it has been an economic push as much as anything else when other alternatives become less expensive or comparably expensive. And then we use more of them, especially if the perceptions of certain types of energy may be safer or more concerning than others. And I know a lot of that is just based on perception and not necessarily reality. And we're going to get into that. But before we do that, let's talk just for a moment. You mentioned natural gas. How does nuclear energy compare to maybe some of the other forms of energy that people might be a little bit more familiar with, fossil fuels, natural gas, and so on?
Sure. Really, where nuclear fits, I would say, into the United States mix, if not the world, is probably the largest, along with hydro power, clean baseload power for the grid. Natural gas, coal, oil had done the same, where they brought a baseload power, less on the clean aspect of power. And then really where the challenge is, and I think where you've seen, the energy markets go, is you've had a lot of intermittent resources be pushed in the last 15, 20 years, most notably wind and solar, to try to go carbon free. But the reality is, kind of the intermittency and the inability to provide the 365 clean power that both nuclear and hydro does. So a little bit of a challenge, but I think we produce about 20% of the power for the United States, just under 100 reactors in the country.
So let's go a little bit deeper on that. You mentioned the reliability of things like solar, like wind, and so on. So just tell us a little bit more about how nuclear energy would compare, both in terms of reliability, scale, and also sustainability in the environmental aspects.
Sure. I think one of the key pieces of nuclear is that it's a very dense energy product in the sense that you can produce large amounts of power on a very small footprint. What we started to see, I think, with some of the plant shutdowns, over the last 10, 15 years, is you were taking assets of 600, 700, 800 megawatts that may be on a total industrial footprint of under 100 acres, and really the nuclear island in those, even smaller on those sites. And they were providing power 90, 95% of the time. So, you're getting good runs for the 2-year operating cycles, where if you were to try to build out the same thing in solar or wind, much, much greater expansion of land needed for much less reliability factor, in the sense that, wind and solar, 25, 30, 35%. So, if you were to replace 1,000 megawatt nuclear plant, you'd have to build 3,000 megawatts of nameplate capacity because of how much less they run than the reliability of a baseload, nuclear plant.
So give us a perspective from the standpoint of scale or what have you. You're talking about, that type of capacity for wind or solar. What does that mean in terms of like the space relative to nuclear, or, can you put that into some perspective for us?
Yeah, there's a number of different kind of resources out there that, we're on a podcast. It's a little tough to show a map,
right?
But there's a number of things out there that you're talking about hundreds and hundreds and hundreds, if not thousands of acres, try to find the same, kind of capacity that you would do in a small, footprint for nuclear. And they talk about offshore wind again. It's, large swaths of land in a very difficult environment to provide power reliably. And I think that's some of the challenges you've seen. You've seen some of those wind projects, especially I live in the Northeast. So, the Northeastern states have had a challenge kind of building out what they thought were going to be pretty easy projects.
So in your view, is this an and or an or? So in other words, anybody who drives the landscape of the United States, we see the wind turbines, we see the big arrays of PV panels and so on. Are you thinking that nuclear replaces that, is additive to it? Do they complement each other? How should we be thinking about that?
Yeah, I think it's very much complementary. I think really where wind and solar can be beneficial if you pair them up with like some battery storage is, taking the peak of the grid into the account, having that ability to kind of meet the peaks where, nuclear, hydro, and right now, obviously mostly natural gas, meeting that base load, 24/7 capacity. So there's a place there for them. I think the one challenge you find, and it's a public perception, is wind and solar are seen as clean and green when in reality, they have a lot of waste. The timeline and the lifespan of those projects is a lot shorter, and there's no way to recycle those materials. They just get buried. So, as much as you view it as clean and green, it still has its challenges like any other energy producer.
And I want to talk about that public perception you bring up, because you're right. You think about solar, you think about wind, and it's certainly in terms of creating the energy once the infrastructure is in place, ignoring for a moment the ROI side of things, which is a whole separate conversation. People view that as, well, it's the sun is shining, the wind is blowing, this is renewable, this is sustainable. And I think for an entire generation or two of Americans and global citizens as well, question about whether the safety aspects of nuclear are such to outweigh or to justify the use of that technology. So, talk a little bit about, do you see public perception of nuclear changing? Has it changed in this recent generation as we think about the importance of producing energy that's reliable, that's economical, but is also clean and sustainable?
Yeah, no, absolutely. Great question with a little to unpack there. I say this often when I speak publicly. I'm 43. My generation, right, wrong, or indifferent, grew up kind of getting their knowledge on the nuclear industry from The Simpsons. And the majority of that is wrong. So, some of the challenges you face is just trying to explain to people what spent fuel is. You definitely have a push younger generations and seeing the benefit right now. It's been a long time coming, but nuclear power, pro-nuclear power, perception nationwide is over 50% for the first time in a long time. And you do have kind of that generational split. The older generations, whether it's the stigma of nuclear related to weapons, not power, or, kind of the harkening back to 3 Mile Island. There are some challenges I think you face with the older generations, but you've seen a lot of that change with the younger generations. Understanding that this is a technology that is more mature. It's been around for over 60 years, and we continue to perfect, this as we go forward. being in this industry and coming over from government to do nuclear for the last 10 years, the attention to detail, the attention to safety, kind of the multiple layers of defense in ensuring that these plants are safe and run well is untested, I think, in any other, industry. The training involved, the professionalism, it's a really fascinating industry to be in. That really does take it seriously. Now, you have that public perception of, when you get into a conversation on nuclear power, well, but what about 3 Mile Island? What about Chernobyl? What about Fukushima? And you look at it and, you can trace back, the issues that occurred there where, there was some operator error at 3 Mile Island that caused, that to occur. Chernobyl never would have happened in the United States, just not a reactor type that the United States would have built without a containment. And then the reality about Fukushima, having worked at a plant with a similar design, the plant reacted how it was supposed to the earthquake. Really, the challenge was the backup fuel supply that would have provided them with 7 days of power was above ground and went out to sea when the tsunami came. So really something that what it did was spur a lot of discussion in our industry about, okay, how do we continue to harden it and improve safety? So I think, when it comes to nuclear power, the consequences could be, quite large, but the incidences are quite small in the industry. And that's really, I think, a testament to the workforce that has done this for 60 years.
Absolutely. And we're going to talk about that workforce in a little while and about the skills and the competencies and the training and so on that go along with the nuclear industry. Looking forward to getting into that conversation. Before we do that, I will note that it sounds like as many great lessons as we can learn from The Simpsons. The understanding of nuclear power and technology isn't necessarily one of them. So we'll remember that the next time we watch an episode. So I love that reference. Absolutely. Speaking of this whole issue, though, of recommissioning nuclear reactors, things that are happening inside of the industry that you spend so much time in, I should note that you and I got connected actually through your CEO. I was fascinated by the fact that you're recommissioning a power plant in Western Michigan, which isn't too far from where I live, right across Lake Michigan, as a matter of fact. And so that's how we got connected. Until then, I didn't know a lot about Holtec International. I saw that you were working on this reactor and this plant, and I was like, wow, seems like a really cool thing. I'd like to learn more. I'm guessing our audience probably fits into the same mold. So what should they know about your company before we go a little bit deeper into the work you're doing?
We jokingly say internally, we're the biggest company in nuclear no one knows about. Company started back in 1986, really focused initially on building heat exchangers and then quickly kind of pivoted. And I'll say has kind of been a leader in staying ahead of what's happening in the nuclear industry. We were responsible for designing the spent fuel racking systems that went into 100% of the pools in the United States to keep those pools subcritical, because obviously the Department of Energy is responsible for fuel ultimately. We don't have an interim storage. We don't have a permanent repository for fuel. So we needed to keep those pools subcritical. So we designed that. And then the next step on from there was to design the dry fuel storage system. So to take it out of the spent fuel pools and then safely store it at each reactor site. We have about 70% of the U.S. market. We have our dry gas storage systems at. And then it was really, I think up until about 2018, we were really more of an industry-focused company where we were a supplier of goods and services to the nuclear industry. We're the largest exporter of nuclear goods internationally in the U.S. 2018, where I was, working at an operating plant at the time, but understanding my plant was shutting down, Holtec saw an opportunity to get into the decommissioning business because we did see kind of the need for, if you're going to run a full life cycle on these type of plants, you have to show that you could design, build, operate, and then clean up, decommission, and safely store the fuel. So with our fuel expertise, we really felt like we had an opportunity to jump into the decommissioning market. We have become the largest decommissioning company for nuclear plants in the U.S. with plants in Massachusetts, New Jersey, New York, Michigan. We can talk about a little bit more Michigan piece, but initially all taken on to decommission. 2 years ago when we took on Palisades when it shut down in 2022, had an opportunity and actually a lot of support from the state of Michigan that was kind of surprising. I mean, traditionally support for nuclear power has been, a Republican issue. It's much, much more bipartisan now, which I think is where we're seeing a lot of the support. But the Michigan governor came and said, is there any chance you guys potentially could restart this facility? So we went into the idea of let's see if we can recommission a plant. It's never been done before, but we're willing to take on and take that challenge. And I'm happy to say we're working towards that.
Awesome. So when you say it's never been done before, this is like the first project in the history of mankind where a nuclear power plant has been recommissioned. Is that true? Or what are the unique aspects of this?
Yeah, when I say it's the first of a kind, it's a plant that specifically went into decommissioning. So when the plant was shut down, there's what's called a letter of permanent cessation of operations. You basically tell the NRC you won't put fuel in the reactor again. No plant had ever come back from sending in that letter. We had a long talk with the NRC saying we think it's still within your regulatory framework for us to be able to work through that. So we have a bunch of licensing actions, I think 7 major ones with the NRC currently working through this process. But there's been plants that have been offline, for multiple years, but they never went into decommissioning. So they've come back in the sense that they've taken some 3-year, some 10-year hiatuses to be able to come back to power, but you never destaffed and headed down the decommissioning path and came back before.
Got it. So in some ways, you're right in the middle of being part of nuclear history. It sounds like it's got to be an exciting time for the entire company. How many people work at Holtec?
Yeah, we got a little over 2,000 now. It's grown quite significantly. I think just this past year, we've hired over 600 people. A lot of that is to restaff the Palisades plant. We had been down to about 220 staff members we went into decommissioning, and we're already back up over 550.
Wow. So you restaffed in a relatively quick period of time. And so I got to believe a lot of those folks that came back were people that were working there prior and came back to their previous jobs. Is that correct or no?
Yeah, we had a good number. I'd say probably a little less than half came back.
Okay.
In the sense, some had gone south and stayed with the former operator. But we've brought a lot of new to nuclear, and we've brought a bunch that were in the industry at other plants that have come to the site.
Got it. So lots and lots of changes. In this case, a plant that was on the road to decommissioning had been decommissioned. Now you're bringing it back into activity and into performance. So really exciting time for that particular endeavor and an exciting time for nuclear technology in general. I've got a really good friend, actually former guest on the Tech Ed podcast by the name of Bill Berry, and former Navy SEAL. Bill's a CEO of a pretty significant manufacturing company in Southeast Wisconsin. And he is fascinated by what we call small modular reactors, or SMRs, micro reactors. And these new technologies in nuclear have been getting a fair amount of attention. Tell our audience, first of all, what is this? I mean, how does that differ from like the full-on nuclear power plant they may have been familiar with in the past or in the present? And also, how does Holtec view that technology?
Yeah, sure. So I'll answer the second part first. We're a developer of SMRs. So we have a design for a 300 megawatt small modular reactor. We are looking to roll out our first 2 actually at the Palisades facility. Once the restart's completed, we'll be looking to license and start construction on those 2 reactors. To us, it's really, what most people are kind of used to is the typical 600 to 1,500 megawatt large scale reactors. Some sites have a couple of, 1,000 megawatt reactors, depending on the site. So they're used to the ones seeing the ones with the big cooling towers. So I think that's kind of everyone's, kind of perception when you first think of nuclear. But really what small modular reactor is, kind of those taken down. So our design is a pressurized water reactor, which is the most well-known and most used reactor in the United States right now, just brought down to a smaller footprint. And really the idea is to be able to deploy multiple units at a site, small footprint. And then really the benefit you have there is instead of when you do a refueling outage at a particular unit, instead of taking 1,000, 1,200 megawatts offline for a month, you're taking 300 megawatts at a time. So it actually helps with grid stability. Now, the real key piece of what we're trying to do, and I think where finally I think the industry has understood, I won't say sins of the past, but just kind of some of the challenges that we faced in deploying it fleet nationwide was, kind of the modular, the M in small modular reactor is key, because what we're doing is we're looking to design and build these in factories and bring them to site and assemble them. It's a good cost control. It's a good quality control to be able to do that, but it really will allow us to deploy, kind of these resources quicker, more efficiently, and with enhanced safety, compared to some of the older designs.
So as you think about scalability of that technology, building it, implementing it on the site of a current nuclear reactor certainly makes sense, probably a good spot to experiment with it and so on. If we look forward, 10 and 20 years and think through how this might change the world of energy, do you see an implication there? I mean, what's the world going to look like 10 or 20 years from now with regard to SMRs?
Yeah, I mean, my hope is that we've standardized the design. You have 4 or 5 companies that, have standard designs that can be rolled out quickly. I mean, the reality is it's not a winner-take-all business. You're going to have multiple companies doing this with proven technology. One of the things I think that's a challenge, and we'll get into it, I know, is the workforce. We've had a lot of challenges, as the industry has slowed down. You have less people going into nuclear energy. So, I know some people like former Miss America Grace Stanke has tried to make, nuclear cool again and get people interested. But I think if we're successful, you're going to see a good mix of both SMRs and kind of the large scale plants rolling back on. I mean, you had the 2 units that came on down in Georgia, the AP1000s down at Vogel earlier this year. Those were huge milestones for the industry and trying to help build. But if you look at the DOE liftoff report that just got updated, to your point, really the easiest place to potentially deploy new nuclear is at existing sites or decommissioned sites because, you have some public knowledge of these sites. You have the benefits, the risks are known. You have the infrastructure. And just based off of, kind of an initial look at that report by DOE, you're talking 60 to 90 gigawatts of power potentially. A lot of these plants were designed and built with multiple units in mind, but for whatever reason, be it the fallout from 3 Mile Island or just associated with it back, in the 80s, you saw a lot of the projects canceled where you should have had 3 units at a site, you only have 1. So there's still ability to kind of input new nuclear into those sites.
Got it. We'll be sure and link up that report in the show notes, by the way. So if our audience is interested in learning a little bit more about that DOE report that you just referenced, we will place it there where we place all kinds of great resources every time we have an episode here of the Tech Ed Podcast. Amazing show notes that we have on this particular podcast. So don't forget to check those out. We'll tell you where to find those when we're closing in on the end of the episode. We're nowhere near the close just yet, and I want to talk with Patrick O'Brien, the Director of Government Affairs and Communications for Holtec International now, about the applications of artificial intelligence in nuclear. We're big AI fans here at the Tech Ed Podcast. We don't let an episode go by without talking about artificial intelligence at least once. How is the advent of artificial intelligence and not just the advent, but the incredible innovation and the speed of innovation in AI and machine learning having an effect on the work that you do?
It's a fascinating question. I think from the kind of global scale, obviously the need for AI and the deployment of AI is driving nuclear's, and I hate to use the word, you used it earlier, but I hate the word renaissance, but I'll use it in this particular instance, because we've seen so many renaissances that didn't come to fruition, which I feel like it's different now. But really, AI is going to drive that, kind of that need for the clean 24/7 large scale baseload power. AI is driving that. Now, on the internal terms of what you're doing, I think where you see advantages for AI, obviously the nuclear industry is very risk adverse and very careful when it comes to cybersecurity. So there's some challenges there, I think, with integrating AI directly into operating plants and things along those lines. But where it can be very, I think, beneficial is from a timings perspective when it comes to evaluating applications that may go into the NRC for design reviews. The amount of paperwork and time that it takes for reviews of that magnitude. I think there's an aspect to be able to integrate AI into helping both write those in a way that makes more sense, but also review them in a way that can quickly identify kind of maybe issues in an application. So I think that's where it's headed, internally. I think it's going to be a lot harder to integrate it into kind of the operations of the plant. As much as we say, these plants are walk away safe in the sense that you don't have to have operators there to make manipulations to safely shut down a plant. That automation tends not to be AI driven for a number of reasons.
Sure. No, I certainly understand the cyber side of things in it as much as we think about manufacturing plant, for example, and the concerns about AI and making sure that we're air gapped in certain ways and making sure that we've got good solid firewalls and that bad actors can't get at the assets within a manufacturing facility. Obviously, the implications of doing that in the world of nuclear could be that much more dire. So understand the reticence or at least the concern about making sure that if we are using AI, we're using it in a safe and sensible fashion. With that said, I got to believe that in terms of how we're advancing technology and how we're changing and innovating across every single sector of the economy, that AI probably will have its impact on your space as well. It'll just be interesting to kind of sit back and watch how that works. The other thing that's been interesting to watch is how we can consider and think about the entire nuclear life cycle. As to your earlier point, it's not just what's happening necessarily in the nuclear reactor, but it's also how are we handling and disposing of spent fuel and storing it and so on. As you think about that entire life cycle, Patrick, are there innovations happening in that space as well that our audience should be aware of?
Yeah, no, I think there definitely are. We're at a unique time, I think, when it comes to, the power generation. I think with what occurred with Russia invading Ukraine really, I think, challenged a lot of kind of how we viewed it. Majority of the uranium for the fuel cycle really was being pulled out of both Russia and China. From a national security perspective, I think we are looking at developing our own domestic supply again, which I think will be key. But really, the other piece of that is you have 60 years worth of spent, hate using spent, because it's been used, but it still has 95% of its available power in those. So while this country hasn't reprocessed since the 1970s, countries like France do reprocess their fuel and reuse it in reactors. And I think, with technology, I think that's going to become a possibility again. DOE started to look at that a little bit, but there's certain states like Arkansas that have gone forward and said, hey, we would like to potentially evaluate that as part of it, I'll say a nuclear economy where you may do interim storage, you may do reprocessing, and then use that fuel to put in the new reactors that then, for a state like Arkansas, that's one of the largest, if not the largest steel producer in the United States, they would like to power their blast furnaces from nuclear. And it's kind of this nice life cycle, economic development engine. So instead of waste being waste only if we waste it, it can be a resource going forward for generations to produce more clean power.
Obviously, anytime we can reuse any natural resource, that's gonna have a positive effect on the environment and on efficiency, and so it'll be interesting to watch that as well. I didn't realize that. What did you say about Arkansas, the largest steel?
Yeah, they're the largest steel producer in the U.S. I was shocked when I found that out, but yeah, some of the conversations I've had with some of their officials is, hey, we would love to see more nuclear deployed, and here's what we think it's complementary to. And you're starting to see that. It's really interesting. New Mexico, there's a company that proposed microreactors to assist gas and oil production, which, it almost seems counterproductive when you think about, the different aspects of energy interacting in that sense. But, instead of them using kind of diesel pumps and generators to get the gas and oil out of the ground, they think there's, potential in using nuclear. So kind of synergistic in ways that you didn't think would be there.
Yeah, absolutely. That's absolutely fascinating. And I think about steel production. I think about states like Ohio and Pennsylvania and Michigan, and Arkansas would not have been on my list. So that's fascinating. And then being able to power the blast furnace using nuclear energy, fascinating as well. So little is known, I think, by the general public about nuclear for a whole variety of reasons. But I've got several reactors not too far from where we live. One of them is decommissioned. The other one is still active. But you drive by that facility and you look at it, and it's got this mystique about it, and it's a nuclear power facility and what have you, and it's got this big fence around it with all kinds of signs and barbed wire and whatever, and it's like, my goodness, I don't know what goes on in there, but I'm never getting anywhere near it. For those of us who have never been through a nuclear reactor, and I'm guessing that's the vast, vast, vast majority of certainly the American public and our listeners here on the Tech Ed podcast, what goes on behind the fence? What goes on behind those four walls? What does the workforce look like? And particularly as it relates to some of the more technical, like technician and operator roles that are in there.
Sure. No, it's great. It is. I think that's one of the biggest challenges is kind of demystifying nuclear and helping the public understand it's not as simple as hosting an open house and letting everyone come through and see it. One of my favorite things I used to do was I would bring reporters into my plant when it was operating. I'd bring them up on the refuel floor. I'd have them stand over the reactor, not knowing they were, and then ask them, hey, where do you think the reactor is? And they would kind of freak out a little bit. But I said, yeah, you're over 20 feet of concrete. But we have, at these plants, a very talented workforce, single unit plants. You're looking at about 600 employees, dual unit plants, you can be upwards of 1,000 at a site. But, the professionals, the operators that are there 24/7, 365, working nights, weekends, holidays, spending Christmas with their shift mates, not with their families. I mean, it's a really, really tight industry in that sense of very, very highly qualified, workforce, especially the operations staff. I always found it fascinating that every 6th week they go and spend an entire week in training, and they have to pass their tests every 6 weeks to ensure that they on shift. There's no industry in the world that does training like nuclear. And then really, your kind of key specialties, obviously you have maintenance, instrument and controls, but the radiation protection folks and what they do to ensure that there is minimum dose, not just the workforce, but potentially to the public as well, and what they do to ensure that the materials stay inside the radiologically controlled areas and people stay safe is just an amazing level.
Absolutely. So I can understand the instrumentation side of it, and we talk a lot about process control and those types of competencies here on the Tech Ed podcast. So there's that aspect of it. Probably not maybe to draw a parallel. You think about an electromechanical technician in a manufacturing plant, probably some of the same skills, or maybe a food production plant or a waste treatment facility on the process control side. What about the operators and some of the other folks? What kind of training, what kind of certifications? What kind of skills? What are they coming to you with, or what are you training them on once they're there?
I would say it runs all the gamuts. Actually, this week, it just broke this week, Nuclear Energy Institute been working on and just put out what's called nuclearworks.org. So it's a really kind of fascinating website to try to bring people in. If they're interested in nuclear, you kind of go onto the website and answer a few questions. And it basically shows you that anyone from a high school diploma to a doctorate, what are your options in the nuclear field? You can kind of work your way up. I mean, if you have a high school diploma, there are people that, at a minimum, that's all you need to kind of become an operator. Now, you need to have the knowledge and the technical abilities to pass 2 years worth of licensing, very intensely pass the NRC standards to become an operator, but there's no special training in that sense. The plant that I worked at, a lot of the operators came out of a local state university that was in Massachusetts, which is Massachusetts Maritime Academy. Had a great pipeline of nuclear engineering students that came over as operators. So it's really
those are people earning a bachelor's degree. Is there a bachelor's degree in nuclear power, or what kind of degree is that? Yeah.
What they were doing was earning that kind of bachelor's in nuclear engineering and coming over. Obviously, some of them would stay on and do the master's, but you could just come off and do the training. One of my favorite stories we were shutting the plant down. We tried to show the human side of nuclear power, which I think is something the industry hasn't done the best job of in the last 25 years. But we had a woman who was an operator in the plant. She had started as a janitor and started working nights and worked her way up and went into the training and, rose her way from janitor all the way up to control room supervisor. And actually, subsequently, when we shut down, she went over and she was one of the first people to work on and help start up the Barrakesh units over in UAE. So that's where she's been for the last 5 years since we shut down. So it's, I think nuclear has opportunities for everyone of any education level and commitment. There's a lot of skilled labor in these sites as well when they're operating.
Does Holtec, certainly skilled labor, tons of skilled labor inside of a nuclear energy facility. Does Holtec partner with, or do your clients partner with technical colleges, high schools, community colleges? Or you mentioned the university. Are there other sources of training and other partnerships you've built?
Yeah, I think the answer to all of those is yes. We're doing some unique things, especially related to our Camden manufacturing facility, where much like when a high school athlete decides to sign with a college, to go play D1 sports somewhere, we've been doing signing days for, high school students that are looking to come over and work in our welding program, work in our engineering program, things along those lines where, we try to make it the same kind of experience and focus. Well, yeah, we're making those pipelines, as much as possible open right now because there is a big shift. When we shut down, more than 50% of the people at my particular plant were retirement eligible. So you had a workforce that was aging as it was that you really needed to kind of staff up. And to your point, there was a lot of colleges that over the last 15, 20 years really either reduced or eliminated their nuclear engineering program because they didn't see it as kind of a pathway to a good job in the future because the industry was shrinking.
Got it. So are you aware that we have a new president coming in? I don't know if you've heard any of these stories, if you watch the news at all, but
based on the fact that I was in DC the last 2 weeks, kind of checking out with some of my friends on the Hill, what we were to expect for the next, at least 2 years, this Congress. Yes, very much aware.
So you're aware that that has not been a secret here in the United States of America. Interesting times indeed. It's going to be fun to watch. I watched Governor Doug Burgum of the state of North Dakota, who actually, as of last week, as we record this, is no longer the governor of the North Dakota. But he is the next Secretary of the Interior, pending his confirmation by the U.S. Senate. He'll be working closely, of course, with Chris Wright, who is going to be the Secretary of Energy, again, pending confirmation. But some really interesting things, I think, going on with the National Energy Council being created, finding more opportunities for Interior to collaborate with the EPA, to collaborate with the Department of Energy, and really have a cohesive, thoughtful, and intentional strategy around energy, and people can agree or disagree with all kinds of things and who's the president and what the administration looks like and so on. Setting the political side of it aside, I think we're in for some interesting times as far as what's going to happen with U.S. energy policy. How do you think, especially fresh off of this trip to Washington, D.C., the next administration is going to impact the use of nuclear energy in the United States?
Yeah, I think based on the first 4 years of this administration, we assume that they've been generally positive towards nuclear. I think the interesting piece we're looking at is what does that mean from a financial perspective? Does that mean, kind of the similar support that I think you saw out of the last 4 years out of the Department of Energy's loan program is, are the tax credits for investment and production Are those still available for nuclear, or is there a push to eliminate those, as a whole, regardless of energy technology? I think we would make the case that you'd be able to do that for some. But if you really want to get and stand up new nuclear, I think you need to kind of do that carefully and ensure that those are still there to help, at least the first few of a kind deployments. I think we're cautiously optimistic. There's a lot of bipartisan support. We've joked for a while in the industry that, I don't think the Democrats and the Republicans in DC agree on anything except for nuclear power. And it just blows our minds that that's the one issue they've coalesced around. And I think we saw it firsthand in Michigan, where you had a Democratic governor come to us and say, "Hey, can you keep a nuclear plant running, or can you restart a nuclear plant?" And that was unheard of 10 years ago.
Absolutely. Well, and it's not just nuclear. The only other topic on which they tend to agree on a bipartisan basis is technical education. And so we're in a great space here in Tech Ed. Everybody recognizes the importance of creating the next generation of skilled talent, technicians, advanced manufacturing in the energy space. So many different aspects of our economy. And, to your earlier point, with significant portions of our workforce continuing to reach retirement age, be retirement eligible, think about what comes after their careers, and creating these huge opportunities for young people to really, kickstart their career in all kinds of markets, including nuclear. Did you get a chance to spend any time with Elon or Vivek when you were in?
No, they were on the Hill the same days, but no, I didn't run across them. And one thing you just said threw a light bulb on too. And, I think, we've seen this in Michigan, and it's one of those things where I think the push to deploy new nuclear, while AI, I think, is going to drive a lot of this. There really is, I think, a general consensus of wanting to bring back, manufacturing, advanced manufacturing back to the United States. And one of the key things is, well, how do you provide the power that those need to be able to pull that off? And one of the examples I use is there's a company called Micron that is committed to building a big factory, obviously in New York, that has the potential to basically use the same amount of power as the state of New Hampshire and the state of Vermont combined. And how does the New York grid provide enough power to that? So it's those type of challenges where it's kind of like chicken and egg. You want to bring back manufacturing, but you need power. Well, how do you build the power to bring the manufacturing? So it's kind of a fascinating time that I think it all kind of fits in together. And hopefully the next 4 years, we can kind of solve some of those problems and get some things in the ground.
Well, for sure. And I mean, that's just a fascinating and fantastic kind of convergence of different ways of thinking about this. So, right. So on one hand, we're like, oh my goodness, what percentage of our microprocessing technology is coming from Taiwan? What happens geopolitically if something goes on over there? Chips and Science Act, we actually had Senator Todd Young, who co-sponsored that bill alongside Chuck Schumer on the podcast not too long ago, talking about the benefits of the Chips and Science Act. A big part of that is what you're seeing with companies like Micron investing in microprocessing technology and capacity, manufacturing capacity here in the United States. Then you think about a state like New York, and there hasn't been any secret that they've had their fair share of grid issues over the course of the last 3, 4, 5 years, whatever it's been. Remember the stories from a couple of years ago, all of that converging in terms of, look, energy doesn't just come, out of thin air. We've got to produce it. We have to produce it sustainably. We have to produce it safely. We have to produce it economically, have to produce it sensibly. And nuclear, this conversation with you here, Patrick, just underscores my belief that it has to be part of the solution. And we think about, how we create clean energy. And there's still a huge portion of our globe, believe it or not, that is creating their energy using, by burning wood, right? I mean, there's all kinds of third world countries that are still, burning down forests to be able to heat their homes and to be able to prepare their food. That's about the least energy efficient. I mean, we think things like, fossil fuels are energy inefficient, or at least not sustainable from an environmental standpoint. The least efficient way you can do it is by burning wood. You go through the continuum from that, to oil, to natural gas, to, coals and somewhere in there as well before natural gas. And then you get all the way up to about the cleanest way that we can produce our energy is through exactly what you're doing, and that's nuclear power, and it's got to be part of the solution. Before we ask our last question, it's just been a fascinating conversation on that particular topic with you. I've learned a ton, and I know our audience has too. And I want to finish our time today with Patrick O'Brien by asking him the same question that we love asking every single guest here on the Tech Ed podcast. We've gotten some phenomenal answers, advice for young people. We have a lot of young people that listen to this podcast every single week as they think about the future of their careers and as they think about their futures in general. If you go all the way back to when you were a sophomore in high school, Patrick, maybe a 15-year-old young man, and if you were able to sit down with that person and give them one piece of advice, what would that be?
That's a great question, and one that I find fascinating for a number of reasons, because I will say that when I was 15, the actions that I did led me to where I am now, unbeknownst by design. I would go back and tell them, make as many connections as possible and keep those connections. I'll tell you what, I started at 15 pumping gas at my local gas station. Unbeknownst to me, the guy who owned that went on to become a state representative in Massachusetts. When I was at college, I went to go to school to be a history teacher and a baseball coach. Halfway through my sophomore year of college, I said, you know what? I don't think I can stand up in front of a room full of people and talk. So my joke is always, I got into politics instead. Started working for that state representative, spent 5 years with him. That led me to work for my local community, which then led me back down to the local plant, which led me into nuclear. So, at 15 to sit there and say like, pay attention to what you're doing. There's people watching, make those relationships, appreciate those relationships. The reality is you just don't know where people are going to end up. I mean, when I interned, I have friends that are now secretaries, in government, they're state representatives, they're business owners, and that network will always help you in life. So really keep those connections and try to meet as many people and ask questions. I mean, ask questions and be educated on these things, because as much as I knew at 15 that my town had a nuclear power plant, I kind of laughed. I never would have thought I'd be working there.
Yep. And here you are. And, that's a really, really good point about hanging on to those connections. And I tell young people all the time, first of all, a lot of my good friends and professional connections earlier in my career are still people I'm really, really tight with, lots and lots of them. So you kind of build that network over time. You assist each other. Now, a lot of times it's their kids that are coming to me and saying, hey, I'm thinking about a career, thinking about what I should major in college or what I should do after high school or what have you, and being able to sit down with those individuals. And first of all, people want to meet with you. They want to help you. Don't ever hesitate to pick up the phone or to send an email or to send a text to somebody in your network and just say, hey, will you sit down and give, I've got some questions for you, or I'd really appreciate your advice. It's amazing how people will help you out. Obviously, Patrick, people have helped you out throughout your career because you've been very astute and very focused on keeping those connections. And it's so much so that would be your advice to your 15-year-old self. So well done. I'm looking forward to keeping this connection. You've been just a really fascinating, insightful individual for me, helping me understand, a market that I had some knowledge of, maybe better than average knowledge of, but there was still a lot more that I didn't know. And it's really been fascinating to get your take on what's happening in nuclear. Optimistic for the future of energy, optimistic for the future of Holtec. You guys are doing some great things and really want to thank you for taking some time out of your busy day and spending it with us here on the Tech Ed Podcast.
Appreciate it very much. Happy to do it, Matt. Thank you.
Always insightful here on the podcast to learn from people like Patrick O'Brien doing things that, in jobs that some of us didn't even know that existed, and recruiting individuals and training individuals for jobs that we don't get to see because they're behind the veil. In this case of a nuclear energy facility, this was a great episode. We referenced some things, including a report from the Department of Energy and other resources that we would love to have you check out on the show notes. You will find the show notes at techedpodcast.com/O'Brien. That's techedpodcast.com/OBRIEN. You can leave the apostrophe out of the name in that particular URL, techedpodcast.com/O'Brien, OBRIEN. As always, check us out on social. We are all over. You'll find us on Instagram, on Facebook, on LinkedIn, on TikTok. Wherever you go to spend time with social media, you will find the Tech Ed Podcast. When you're there, say hello. We would love to hear from you. And until next week, my name is Matt Kirchner, your host. Thanks for being with us.